got one very basic question. I picked up an ESP32 initially, wanting to use the Bluetooth low energy stuff to pick up from a couple of temperature and motion sensors, but great difficulty trying to get I just want to pick up the advertisements, so I don't want to connect. I just want to pick up the advertisements, and the AIO BLE library. They seem to be totally focused on connection, and the advertisements are basically cut off before you actually get to the data. You're not actually seeing where the information is. I ended up getting what I wanted. Got a Pi Zero happily talking to the same devices, so they don't actually connect. They just pick up the advertisements. And I was thinking, well, in theory, this should work and avoid the hassle of connecting, but in practice, I think I'm going to have to learn a whole lot more to get into the low level, either get into the low level Bluetooth stuff on the ESP32 or work out what the Python that's working on the Pi Zero, working out what it's doing, and can I translate that back into the MicroPython?
Yeah, right. AIOBLE shouldn't need to be based on a connection. You should just be able to do like scanning with it. And that would be normally how you would detect like beacons and those kind of advertising sort of devices.
Yeah.
But without knowing exactly what you're listening for, it's a bit hard to.
It's just that one of the little Xiaomi Measure temperature humidity ones. They're sort of $5 or $10 each, and so the broadcast, the advertisement clearly broadcasts both the temperature and humidity, right. But the AIOBLE picks up what I can see from that is only the first part of what it's transmitting, and it sort of seems to become corrupted before I get to the bit of the advertisement which has got the data in it.
Have you used? There's an option when you're scanning active equals true.
Okay.
That I think will help you out.
Okay.
The reason is that with BLE devices, when those advertising packets are of a very limited size, which is the pure advertising part of that packet, the active equals true allows it to, when a device is detected, how to explain this? The MicroPython device can then go and ask for the extended packet of the BLE. So I'm probably explaining that a bit wrong. Andrew, you've played with this a bit more or not?
Not recently enough, sorry, but
yeah,
in terms of getting the content back out of the beacon or the beacon advertisements.
Yeah, I haven't done much with beacons, but the doing an active scan as opposed to the pure passive one should allow you to get the extra data. I believe.
Okay, because the software on the Pi Zero is described as a purely passive scan.
Yeah,
and it's picking up, or it was written just to pick up these particular temperature and humidity sensors.
Okay.
But I've actually been able to extend it to pick up. There's a little motion and light sensor,
right?
And it works which actually puts out a much longer advertisement. But I can pick those up in detail and process those as well.
Okay.
So yeah, I've just got to persuade the MicroPython device
to listen properly.
I'll have a look at that.
That's from the client side.
Be shocked if there's not some way you can't get at that data. Just need to figure out what it is. I'm just looking through the code now, how it all hangs together. Bruce, if you could also send me through the device you're using, I'll be able to get my hands on one and try.
It's a, well, I know it's an ESP32, but it's not a board which.
Oh, I'm sorry, I mean the temperature device. Yeah.
Oh, the temperature device. It's a Xiaomi MIJIA. It's a little square.
Oh, look at that. It's in my history.
What's that?
Oh, look at that. It's in my history.
Yeah.
Yeah. Yeah. Yeah. Cool. I'll take a look.
Yeah, and there's a Quinping motion and light sensor, which works quite well too, except that when it sees motion, it starts broadcasting multiple times a second, which
Floods the.
yes, we've got to filter those out to get anything sensible out.
Cool.
If you're just looking at AIBLE code briefly, if I
Yep.
share this, it looks like once you've done, so if you're running the central on the MicroPython device, I presume, and if you do a Bluetooth scan, the scan should sort of return like individuals or list of these scan result objects.
Yep.
So each scan result should have these attributes in it. So add data should be the raw data from the advertising packet.
Yep.
Response is if you've done an active scan, then the response data can be extra stuff.
Okay.
But yeah, it'll be, I'm gonna assume the data you want should be in add data, but it depends on how you need to decode it from that. Is probably the complexity.
Essentially, that add data. Now, I'm not sure. Where are we?
Yeah, when you just inspect that device, it'll show just the name of it. It won't include that data normally.
Yeah, but I can actually see a result which it puts out the add data and it puts out a string. Well, initially it's a string which I can't use the correct terminology, but it comes back with a whole lot of \x, a couple of numbers. Yep.
So that'll be the raw binary data. Yeah.
Okay. Now, the other software, which is it's on GitHub, is My Temperature 2. It actually takes that raw data and then essentially strips it back to just a string of numbers or hexadecimal numbers. And from exactly the same device, the AIOBLE, basically it cuts off about 2/3 of the way through the string. So I can see exactly the same data. I can match up the first part of the string on each one. So in that, see the temp client?
Yep. At that point, when you're talking about data being cut off, that sounds a lot like the active versus passive stuff, where the rest of the data would often be in the response packet if it's done an active scan. So it doesn't really explain why the other device that says it's doing a passive scan has more data, but in a beacon, in an advertising packet, there is that strict length of, I think, 21 bytes is all the data it can have. So
if I could work out.
By the way, the response data that we're talking about, that actually doesn't require a connection. It's still connectionless. It's just, it's like an extended advertising packet.
Okay.
Yeah.
So that example, I'm just trying to see on that code, does it active?
And I guess I don't really want to put everyone through PLE code.
Yes.
Too much longer anyway.
Yeah, that prints out. Now, where's the print? I'm just trying to find the printout on that bit of code there. Where
I think as it.
So return result.
So that's the find. It returns a device or tries to.
Yep.
But there, that's doing the connecting. It doesn't have a printout of. So in theory, yes, your result.device. Result here will be that scan response data. So you may be able to do a.
Yeah. So the default, now there's a line there which says print result, result name, result RSSI, result ADV data.
Maybe not in this example, maybe one that you've
I think it was in
got.
It was, I thought it was in that example where it does the print.
Might have been a different version of it to something. Yeah, I'm not seeing a print here. It might be somewhere else in the code though.
Yeah, I'll have to. No, but anyway, I'll have a look at that active. So maybe it is that.
It might be a clue anyway, perhaps.
Yeah. Yeah. So I was just using those examples that were coming up there to look at.
See you, Chris. That's major. Barry, I saw you slip in. I just want to say thanks again for putting those videos together. I really appreciate that. You got to mention the slides.
Send me this one and I'll do the same again.
Thank you very much. Really
Give me a chance to see what I missed.
Yeah. It is rather shocking how many devices within barely earshot.
Isn't interesting how long they all look different, but if we yeah, this is doing an active scan by default. So that
yes. Okay, so if yeah, so that's actually, yes, so it's actually doing just found my bit of code. So it's actually doing an active scan.
oh, I got it wrong. What was it again?
I wonder if, maybe I need to look at the response data. Okay, so maybe. Yes,
that would be a fairly good starting point. So far, it's all wrong. I'm developing over the USB mesh storage. It's very dangerous. But for a quick live demo, it doesn't work. It's a none sometimes.
Okay, so it's reaching into the bottom drawer here.
I want to take a look at this protocol now.
But yeah, I must admit, somebody's comment before about the ESP32 not being easy to get into. I mean, I'm only doing basic stuff, but basically, yes, load up Thonny, put MicroPython on it, and it was all just worked. So it was quite.
Oh no, like from MicroPython's point of view, it's a pretty good experience. The problem is the ESP32 has a number of quite interesting low-level peripherals that you still need to play around in C to access, in some regard anyway. Yeah, and that's, once you've got to delve into the ESP32 IDF, it becomes a little bit more complex. Still pretty good compared to a lot of other micro manufacturers, but just for the hobbyist market, that is sort of comparing to the Raspberry Pi Pico stuff, it's different.
So I can't entirely explain everything I'm seeing here because these advertising data are longer than I was expecting. There are a lot here that are longer than I would have thought. But
I'm sure 30 odd is about the limit of the advertising packet.
Yeah, might be wrong. But here's a couple of good examples. So here's one where the advertising packet is 7 bytes long and the response packet is 11. And in the response packet is where there's the name hidden and things like that.
Okay.
Similarly up here, in Shield, there's a 30 in advertising and then another 8 in response, which again, the name's hiding there. So it sort of depends on how the device has been designed, where they put the important data.
Yep.
But hopefully, yeah, see how that goes, whether that gets
actually,
you anyway.
No, I'm just looking at it. So the name seems to be in the response data, but no, the response data has got basically nothing but the name.
Okay.
It's got one and the ad data looks though it's still the same. Yes, it's cutting off. Unfortunately, my ability to take the information off my laptop next to me here and drop it onto the iMac where the Zoom is sitting beyond what I can do at the moment.
Even the data that's in that advertising packet and whatnot, sometimes it's convenient to turn that in, just wrap it in list. Can make it a bit easier to see what the data is rather than when you see it with all the like the string, it's /x value for hex numbers, but then that's interspersed with some of them we convert into ASCII and whatnot. So it can be, they're certainly hard to read. But
yes, no, I confess I just took that string and dropped it into BBEdit and stripped out which I think was what the other bit of software, my temperature 2 software, it was doing that, but doing that in Python, just stripping out the \x's and shoving everything else in together.
That could be, that can go a bit sideways because it depends. If they're all a \number, then you're okay. But if some of them are ASCII characters in the mix there, then that can confuse things. What
I suspect what happens is the end of the looking at the temperature data. For most part, it's the \x followed by two digits or 2 characters, but not always. And it's where it falls apart that the system says, no, I can't handle this anymore. But it no question that it stops. The data string stops before it at almost the point where the other software is saying, well, this bit's the temperature, this bit's the humidity, and this bit's your battery voltage. Yes, there's actually a passive Bluetooth monitor, which is for the Home Assistant package for the Pi.
I was just looking at that. It's Home Assistant got all the code to interface with this thing, so it should be.
Yeah, so that passive monitor gives you essentially a view into the what the Bluetooth packets are for a whole stack of different devices, which was how I was able to take the software which was just doing temperature and add in the motion and light using that extracting it from the other data. But yes, I've just got to work out because on the Pi, on the Python, the AOBLE package on that I recall, did the same thing. It sort of said, oh, I can get this much, I'll give you this much advertising data, but no more. So there's obviously different ways of extracting it. But anyway, I'm probably being perverse by saying I want to do it without...
Mute's cute.
I like that.
Nice little display. Very, very thin.
Yeah, it's a common problem with Bluetooth that it's always a lot harder than you expect it to be and pretty rubbish and unstable and difficult.
Which is why I've sort of said, maybe I'll use my ESP32 for something else for a little, and then come back to the Bluetooth a bit later.
You could make a temperature sensor with the ESP32 that does Wi-Fi.
Say that again. Sorry, Michael.
You could use the ESP32 to make your own temperature sensor device that reports over Wi-Fi.
Yep.
That's always a thing you can do. That's
true, but one of the temperature devices is currently sitting outside. That's where the Bluetooth comes in handy.
True.
Yeah. And, but meanwhile, I've got a walking robot that I had running on with the Raspberry Pi as a brain. So I thought, it's got 9 servos. It should be able to, the ESP32 should be able to drive that. So that's the next project.